Our first example for using the law of cosines is as follows. Find the unknown side and angles of the triangle. So this is a typical side angle side situation where we know one side is 10, the other side C is 12, and the angle in between them is 30. So this is a classical example for application of the law of cosines. So we have the side across from the angle, from the known angle is side B. So we're going to start with B squared equals, and then our formula that we're going to be using is A squared plus C squared minus 2AC and cosine beta. Okay, we know all of the values here. We only need to substitute them. So 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 30 degrees. And when we put all of it in the calculator, I got 36.1539 approximately. But remember, that's my squared B. So in order to find B, I need to unsquare this value. So square root of the answer. I get 6.0128. So it's 36.1539. It's approximately 6.0128. Okay, so I found one of the sides. I still have to find the other two angles of the triangle. All right, so since I know all of the sides now, I can apply the law of cosines for any one of these angles, either gamma or alpha, or I could apply the law of sines as well. So here now you have a choice. But since we're practicing the law of cosines, let's take our second formula when it's solved for the cosine of alpha and plug in the values into here. So we're going to get B squared is actually this value, 36.1539 plus C squared minus A squared divided by 2 times B, which is 6.0128, and C is 12. Again, we need to put it in the calculator in order to figure out the value of the cosine. And I got a 0.55543832. And if you got slightly different number, I didn't round anything. So I even grabbed this number the way it came out first in my calculator right here. So you may have a slight different answer due to rounding. Okay, so in order to actually find alpha, we need to take the inverse cosine of this value. And I got 56.26 approximately, again, rounded. 56.26 degrees. Okay, so now since I know Since I know two of the angles, I can easily find my third angle. Gamma is going to be 180 minus 56.26 minus 30. And that gives me 93.74 degrees. Okay, another reason why I suggest using the law of cosines in favor of law of sines is because with law of sines, you may run into our ambiguous case when you have to check two different angles. So I think law of cosines takes it out of the question. So now I invite you to try this yourself. Here's our problem. We have a triangle with alpha 30, B equals 12, and C equals 24. So go ahead and find the other pieces of the triangle. And pause here, because we're going to move on to our example 2. So here we have a triangle with sides 20, 25, and 18. And it says, find the angle alpha. Okay, alpha is across from side A. So this is what we're doing. Well, we are gonna use our law of cosines. Similar to our previous problem, cosine alpha equals b squared plus c squared minus a squared divided by 2 times bc. And let's plug in the values. All right, and when we put this all in the calculator, we will get 0.61. So to find alpha, we're gonna invert this cosine. Which will give us approximately 52.41 degrees. So this is how you find alpha, angle alpha. You could find all the rest of the angles gamma and beta in the same manner if need be, if you have to solve the entire triangle. All right, so go ahead and try it. This is given A equals 5, B equals 7, and C equals 10. Find the missing angles. So again, here we know all of the sides and we don't know any of the angles. Go ahead and try to find them.